In this course, we've been thinking about the output of the trig functions as the measurement of some length using some other length as our unit ruler given some angle measure. So for example, if we have an angle with its initial ray pointing in the 3 o'clock direction and a radian measure of theta, then if we want to think about cosine of theta, so if we write down cosine of theta, we think about cosine of theta as measuring the terminal point's distance to the right of the center of the circle in units of the radius of the circle. And if we want to compute that value, if we knew that the terminal point was h units to the right of the center of the circle, and the radius of the circle is r units long, then the measure of that horizontal distance in units of the radius can be represented as h divided by r. We're thinking about the output of cosine as the measure of the horizontal distance and units of the radius of the circle. However, we can switch our unit of measure here. So instead of measuring the horizontal distance in units of the radius, we could actually measure the radius in units of the horizontal distance to the right of the center of the circle. If we wanted to do that, we would write this ratio r divided by h. That ratio represents the measure of the radius of the circle and units of the terminal point's horizontal distance to the right of the center of the circle. Now for this given angle, we could actually create a new function. We're going to write it as SEC that takes theta as its input, an angle measure as its input, and then outputs the measure of the radius in units of the horizontal distance to the right of the center of the circle. And this new function here is what we call the secant function, S-E-C-A-N-T. So the secant function, and we abbreviate that as SEC when we write its function name. On the other hand, if we looked at sine of theta, we have the sine function that will take an angle measure as its input, and then the output of sine is the measure of the terminal point's vertical distance, v, above the center of the circle, in units of the radius of the circle. So we can represent the output of the sine as v divided by r. It's the measure of the vertical distance in units of the radius. However, if we instead measured the radius of the circle in units of the terminal point's vertical distance above the center of the circle, we could represent that measurement using a new function. So we could say CSC of theta is equal to the measure of the radius in units of the vertical distance. And this is actually the cosecant function. So we abbreviate that to CSC, but it's just another trigonometric function that takes an angle measure as its input and then outputs a measurement, but it measures the radius in terms of the vertical distance instead of vice versa. Finally, we have the tangent function. So if we input theta into our tangent function, the output of the tangent function gives us the slope of that terminal ray, but the slope of the terminal ray is really the measure of the vertical distance above the center of the circle and units of the terminal point's horizontal distance to the right of the center of the circle. So to actually represent or determine the slope of that terminal ray, we're really measuring the vertical distance of the terminal point in units of the horizontal distance to the right of the center of the circle. Therefore, we represent that as v divided by h. But if instead we wanted to measure the horizontal distance to the right of the center of the circle in units of the vertical distance above the center of the circle, then we could represent that as h divided by v, and we could actually create a new trig function. We'll write this as COT of theta, and the output of that function will give us the measure of the horizontal distance in units of the vertical distance. And this is actually the cotangent function. It's just another trigonometric function. We write COT as its like abbreviated math name, but it's just a trig function that inputs an angle measure swept out from the 3 o'clock position and then outputs the measure of the terminal point's horizontal distance to the right of the center of the circle in units of the terminal point's vertical distance above the center of the circle.